Okay, so let's continue looking at this concept of a span of a set of vectors. And in the previous video, we looked at vectors in R2, which is probably where you're more used to living. But let's think about this same question in R3, which you may not be living in mathematically, but in reality, right? That's the world that we are comfortable living in. So if you have not taken a class like multivariable calculus, then you might not be as comfortable moving around in R3, and that's okay. But if you have taken a class in multivariable calculus, you probably have seen our coordinate system that we typically use in R3. So we could put x1 over here, x2 over here, and x3 over here. So we have our kind of usual R2 plane, which is kind of like the ground, and now we've added a third dimension, which is like how high off the ground or into the ground are we going. So now we're living in this world. And so this vector 0, 1, 1, I can think of as a vector which has 0 units in the x1 direction, 1 unit in the x2 direction, and 1 unit in the x3 direction. So it is actually sitting right over here in the x2 plane, in the x2, x3 plane. So it's kind of just sitting up there. It's moving nowhere in the x1 direction. So if I want to describe the span of this set of vectors where there's only one vector, so the only vectors that are going to be in this set are going to be vectors that look like c times the vector 0, 1, 1. So in other words, this is going to be the set of all vectors that have 0 for the x1 component, and they have the same value for x2 and x3. So these again are going to be a bunch of vectors that sit on the line which is parallel to 1, 1. So in other words, this is going to be all vectors parallel to 0, 1, 1. Okay. The next question 2 is now thinking about what would the span of the vector 0, 1, 0 and the vector 0, 0, 1 look like in R3. And so now we're taking linear combinations of these two vectors. So I can take some constant we'll call a times 1, 0, 1, and then I can take some other constant I'll call b times 0, 1, 1. So in the end, what I'm going to get is any vector that looks like 0, a, and b, where a and b can be any constant that I think of. So there's a difference between the span of the single vector 0, 1, 1 compared to the span of the two vectors 0, 1, 0 and 0, 0, 1. Namely, over here, this in the first question, we get a line, right? Because all of these vectors need to sit on the same line. Whereas over here, we get an entire plane of values. So we're getting any point or any vectors in R3 that sit in this x2, x3 plane. So all I know is that the x1 coordinate is 0, but the x2 and the x3 coordinates could be anything that we want. And so we would call this the x2, x3 plane. So over here, the first question, the span of the vector 0, 1, 1, that was a line. So this winds up being one-dimensional. In question 2, we wind up getting a plane. So this is like a two-dimensional vector. In question 3, we now are thinking about the span of 1, 0, 0, 0, 1, 0, and 0, 0, 1. So now we can move in the x1 direction, we can move in any amount that we want in the x2 direction, and we can move any amount that we want in the x3 direction. So as long as I'm free to move in these 3 different directions, right, I can arrive at any point in the R3. So the span of this set of vectors would be all of R3, which is 3-dimensional. And so for the last one, question number 4, it's asking us about the span of the vector 0, 1, 0, minus 2, and 0, 1, minus 1. And so this is trickier to think about. So we'll take a look at this on the next video.